Alrighty, we got a little test coming up here to finish off Chapter 2, so let's do some practice problems and get ready for that test. Number 1, does this table describe a function? Well, if we look at our inputs, we got 0, 1, 2, 1, 0. We got a couple repeaters, and just one repeater will be enough to disqualify this. We have a repeating 0, and we also have a repeating 1. Again, either one of those would be enough to disqualify. Because remember, if we think about this graphically, if we graph these points, 0, comma, negative 4, so we'd go over 0, down, negative 1, 2, 3, 4. We got a point right here. 0, positive 4. 0, 1, 2, 3, positive 4. You know, those points are, of course, going to fail the vertical line test. And we can see it also with the x values of 1. If we go over 1, up 2, we have a point, 1, comma, 2. And over 1, down 2. Again, we're going to fail the vertical line test. So that's not a function. Evaluate the function at the given value. So we have our function here is h of t, and that's equal to t squared minus 2 times t. So first we're going to find h of 2. That just means we're going to plug in a 2 wherever we saw a t. So we're going to have 2 squared minus 2 times 2. 2 squared is 4, 2 times 2 is 4, and if we subtract them we get a value of 0. Alright, letter B, we're plugging in a decimal this time. So h of 1.5. H of 1.5 is going to be 1.5 squared minus 2 times 1.5. Let me just make sure with the calculator. I think that 1.5 squared is 2.25. Let's see. 1.5, and we're going to square it. Yeah, 2.25. So 1.5 squared is 2.25, and we're going to subtract 2 times 1.5, that's 3. If you got $2.25 and you give away $3, which you really can't do, you're left with negative 75 cents. Negative 0.75. Alright, and the last one, we're going to have a variable in our final answer, h of the quantity x plus 2. So we're going to replace, we used to have t squared minus 2t, that was something squared minus 2 times the same something. And now that something is this quantity x plus 2. So let's simplify this also. Let's square this binomial x plus 2 quantity squared. That's going to be x squared plus 4x plus 4. And then we distribute the minus 2. Minus 2x minus 4. So let's collect up our like terms. We have our x squared, that's all by itself. 4x minus 2x is plus 2x. And the 4 and the minus 4 cancel out. So there's our final answer. Number 3, we have a piecewise function. Evaluate the function at the given value. Remember, here's where you look at first. These are the x values that you plug into the different pieces. If your x value is less than or equal to negative 2, you plug that x into the top piece. If your x value is between 2 and negative 2, your answer is just a 0. If your x value is greater than 2 or equal to 2, you plug it into this piece of the function. So our first one is, f of negative 3. So where do we plug the negative 3 in? Well, negative 3 is less than or equal to negative 2, so we're going to plug that negative 3 in for this x. 4 minus 5 times x became 4 minus 5 times negative 3. And let's see, we're going to have 4 minus 5 times negative 3 is negative 15. And subtracting a negative, we add the opposite. 4 plus 15 is 19. Next piece, f of 4. F of positive 4. And our bottom piece here is for all x values greater than or equal to 2. Of course, 4 is greater than 2. So we're plugging that 4 in right here. It was x squared plus 1, but now it's 4 squared plus 1. And 4 squared is 16, plus 1 is 17. And our last one, C, f of negative 1. Well, let's see, negative 1 doesn't fall into this range, doesn't fall in here. It's in between 2 and negative 2, and there is no place to plug a variable or a number in for a variable. Our output is just given to us as 0. F of negative 1 is equal to 0. Number 4. find the zeros, that should be zeros, of the function algebraically. So we have our function here, x squared minus 4x minus 21. That is equal to 0. And how do we solve these type of quadratics? We factor them. So let's see, we're going to have x times x for the x squared. The factors of negative 21 be 1 and 21, 3 and 7, and I guess that's it. 3 and 7 are 4 apart on the number line, so it's going to be 3 and 7. And we want them to add up to a negative 4. So it'd be a positive 3 and a negative 7, and those do multiply to negative 21. And then to find the zeros, what do we do with each factor? We set each factor equal to 0. So negative 3 there, x minus 7 equals 0 means x is 7. And what does this mean graphically? Question didn't ask us to do this, but let's have a little extra fun. X is negative 3 might be right about here, and x is positive 7 right about over here. We know that squared functions are parabolas. If it is a positive x squared, it's going to open up. So we know we're going to cross at negative 3 and 7, and our parabola opens upward. Does this graph represent a function, y or y not? Of course, this is going to be a vertical line test, and this is going to easily pass it. Let me get myself a line here. Here's our vertical line. We can only touch the function once or none, or no times, to pass the vertical line test. We can't hit it twice. So this is a parabola, and it is going to, yes, we do pass the vertical line test. Yes, VLT. We passed it. Write the linear function that has these indicated values. Remember when I said in class, these are just a different way to write 2 points. So we need to just translate them from that function notation into something we're used to dealing with for writing linear equations. We plugged in a 0, out popped a negative 5, so one of our points is 0, negative 5. We put in a 4, out come a negative 8. So 4, negative 8 is another point of this equation. So the first thing we need to do is find the slope. M equals y minus y. I'm going to go right to left. Negative 8 minus a negative 5. And 4 minus is 0. So here we add the opposite. Negative 8 plus 5 is negative 3. And 4 minus 0 is 4. So we found our slope. Our slope is negative 3/4. Now we need to write the equation. So we're going to need the point slope, y minus y1, equals m times the quantity x minus x1. And we found our slope. That's negative 3/4. And we just need to plug in an x coordinate for that x1. And we need to plug in a y coordinate for the y sub 1. We can use either of these points. I always gravitate toward the ones with a 0 in it, because that's going to make one of these easier to deal with. Here my x value is 0, and my y value is negative 5. So y minus negative 5, that becomes a y plus 5. And that's equal to, we distribute the negative 3/4, negative 3/4 x, and negative 3/4 times 0 is 0. And our last step is we're just going to subtract that 5 out of there. Y equals negative 3/4 x minus 5. There's our linear equation that uses those indicated values. Now here we are composing functions, and first we'll do the easy ones: add, subtract, multiply, divide, and we got to come up with the domain of that division, f divided by g. Here's our two functions. F of x is x squared minus 4. G of x is 3 minus x. So let's start with the easiest one, of course. A, we're going to add them together, f plus g. And since we're adding, we don't even need to worry about putting them in their own set of parentheses. This is just x squared minus 4. And we're going to add to that our root of 3 minus x. Are there any terms we can combine or simplify at all? No, nothing. So we just leave it like that. B, we are subtracting them. F goes first, x squared minus 4. And we're going to subtract root of 3 minus x. Again, there's no common terms to collect up, so we'll just have to leave it just like that. Let's see here, letter C, multiply. So we're going to have x squared minus 4 times the root of 3 minus x. See here, I guess we could distribute. we're going to have the root 3 minus x times the x squared. So we're going to have an x squared times the root of 3 minus x. And then minus 4 times the same quantity, root of 3 minus x. And I guess I didn't need those parentheses. Oops. Not the prettiest, but there it is. And let's see the division, f divided by g. So we have our f function up top, x squared minus 4, divided by the root of 3 minus x. So there's our composed quotient. And we got to worry about the domain of that denominator. And there's sort of two things going on here. Remember, we never want to divide by 0. So we could take our denominator, root of 3 minus x, and set it not equal to 0, because we never want the denominator to equal 0. And we also have a radical. And remember, we want what is under our radical, 3 minus x, to always be positive, greater than or equal to 0. So to solve this first one up top here, I would square both sides. 3 minus x cannot equal 0. 0 squared is still 0. And we're going to add x to both sides. X cannot equal 3. If I look at 3 minus x greater than or equal to 0, I would add x to both sides. 3 is greater than or equal to x, or x is less than or equal to 3. Now this is less than or equal, and this one says x can never equal 3. So we're just going to, sort of combine those together and say x must be less than 3. It cannot be equal to 3 because of this part. It can't be anything greater than 3 because of this part. So just x minus 3. And of course we save the hardest stuff for last. Problem 7 is the composition of the functions. So it says here in part A, we want to find f compose g and find the domain of each also. And then in B we're going to find g compose f. So f compose g is another way to write f of g of x. G of x is the inner function that's going to go into the f function. So I'm going to take the g function right here. This is my g function. I'm going to wrap it up like a Christmas package, and I'm going to plug it in right there for that x. So f of g of x is equal to f of x was something squared minus 4. So we had something squared minus 4. But now that something, that x is going to be replaced with the entire g function, the root of 3 minus x. So the square and the square root are inverse operations. They're going to cancel each other out. And we're left with 3 minus x minus 4. And we can combine the 3 and the negative 4 into a minus 1 minus x. There is our composed function f of g of x. Now let's talk about the domain. This is usually the hardest part for people to get when we first start doing these composed functions. If you just look at the final product, if you just look at this and say, okay, I'm worried about my domain, there's no division, so I don't have to worry about dividing by 0. There are no radicals in this composed function, so my domain is all real numbers. Is that correct? No, it is not. Remember, we have to look at two things. The composed function, which we just did, and what I just put here in this blue box, the domain of that by itself would be all real numbers. But we also have to go back and look at our inner function. Our inner function was this root of 3 minus x. The root of 3 minus x. So the domain of that, we want that to always be greater than or equal to 0. So 3 minus x is greater than or equal to 0, or x must be less than or equal to 3. That is the domain of even the composed function. You got to look at two things: your inner function and the final composed function. Where those domains overlap is the domain of the composed function. Oops, wrong button. There we go. Now let's look at the reverse of that. We did f compose g. Now we want g compose f. So for letter B, we're doing g compose f, which I like to write as g of f of x. So I'm going to take the f function, wrap it up like a Christmas package, and plug it into the g function. So this is my f function. I'm going to wrap this up in a package, and it's going to go right in for that x that's under the radical. So g of f of x is equal to, my outer function is this g function, and that was 3 minus something. 3 minus something. And we used to have an x in there, but now that x is replaced with the entire f function, x squared minus 4. Don't forget to put it in parentheses because we will have to distribute that negative. And we're going to do that right now. 3 minus x squared plus 4. And then we combine like terms underneath the radical. We have square root of 7 minus x squared. So there is our composed function g of f of x. So we need to worry about the domain now. Well, the domain of this final composite function, the square root of 7 minus x squared, we want what is under the radical to always be greater than or equal to 0. And I can add my x squared to both sides, and I'm going to flip that around too, so it's x squared is less than or equal to 7. And then we square root. X must be less than or equal to plus or minus the root of 7. So if we think about this on a number line, we have plus the root of 7 and minus the root of 7, and 0 would be right in the middle. This is our domain. Any numbers up to and including, or any number between up to and including the square root of 7 and the negative square root of 7. But remember, we don't just look at the final domain, or the domain of the final composed function. We also have to go back to the inner function. And here our inner function was f of x. This function here, f of x, the domain of that would be all real numbers. Because there's no chance to divide by 0, there are no radicals. It's just a simple polynomial, x squared minus 4. We can plug in anything we want for x. So the domain of that would be all real numbers. Now, where do those domains overlap? If I did all real numbers as the blue line, that would go on forever in each direction. The only place these functions overlap are between root 7 and negative root 7. So that's our final composed functions domain, from negative square root of 7 all the way to positive square root of 7. Remember, those composed functions, you have to look at the domain of the final composed function and the inner function. Where those domains overlap is the domain of the whole thing. Good luck on the test.